Dear students, in this video we are going to see how to design class A, B as well as class C amplifier. So file, new schematic, we can give the design name. So we are going to design AB amplifier. So before we are going to check the connections, let's see what are the components required to make class AB amplifier. So here you can see two transistor as well as two diodes and resistor as well as capacitor, then input source and output source. So here we can see two transistor, both are opposite to each other. That is, transistor 1 is NPN category and transistor 2 is PNP, and two diodes are required to drive two separate transistor. As name implies, class AB. So two transistor which are going to produces the output but will not be the same. So let me pick the components one by one. So we need two transistors. So on the top of the window you can see the component. You can check NPN and one PNP transistor. Here we are having PNP transistor, and we need a diode also. So diode 1 as well as diode 2, and resistors also required. Let me check. Resistor 1 and 2 and 3. Three resistors are required. So 1, 2 as well as 3, and apart from that we required capacitors 1 as well as 2. That is one input side, one is output side. So capacitor 1 as well as capacitor 2. Then we need input source, signal generator, and as well as output source. So input side as well as output side. So before they are going to make a connections, let me check the components value. So capacitor 1, that is connected at the input side, 100 microfarad. So both capacitors having equal value only. So 100 microfarad. Similarly, right click and give the value 100 microfarad. And resistors R1, R2 as well as R3. R1, R2 both are same value, 10 kilo ohm. R3 is 47. So R1 10 kilo ohm, R2 also 10 kilo ohm, and R3 47 ohm. And what about the transistors as well as diode values? So diode, here we can have 1N4148. So you can directly type the name here. Otherwise, here in diode itself you can find 1N4148. Here you can type. Otherwise you can click right hand side window, it will open and you can check the value. So 1N4148. Similarly, transistor NPN category, it is BC547C. So okay, transistor BC 547C. For PNP it is BC 557C. So BC 557C. Okay, and now we are going to make a connections. Before that, let me check the voltage levels. So at the input side, so here it is sine waveform generator, and we can have some specifications. So here, suppose you want to check only DC value, you can directly give the value, but here we are going to give the input as a sine waveform, so that we have to give the frequency, amplitude, everything. So go to advanced and select sine waveform generator, and here you can check the amplitude as well as phase. Say for example amplitude is 10 volt and 230 volt. So the offset value, amplitude, frequency. Offset is 0 and amplitude here predefined 0 3 1 kilohertz. So 0 3 volt plus 1 kilohertz. Okay, then output side here it is 12 volt. So 12 volt. So now all the values are assigned. Now we are going to make the connection one by one. So rotate this capacitor for our AC connections. So control R, you can select the component and you can use the shortcut control R. So the positive terminal of input is up connected to the one end of capacitor. So here you can select the wire. So the positive terminal of input is connected to one capacitor, and so the capacitor other is connected between two diode. So the other end of capacitor is connected between two diode. Okay, then so diode 1 as well as diode 2 both are connected to resistors. So diode 1 as well as diode 2 both are connected with respect to resistor 1 resistor 2. So we have to connect properly. Okay, so now maybe a resistor other end is connected to the voltage source, as well as the bottom resistor is connected to the input side. So it is connected. Now coming to the transistor connection. So NPN transistor, we have three terminals: base, emitter, as well as collector. So the base terminal of the NPN transistor is connected to the diode, in between actually resistor 1 and diode, and collector is connected to the resistor terminal of 1. So the base is connected between diode 1 and resistor 1, and collector is connected between resistor 1 and the output side, and the emitter terminal of first transistor, that is NPN, is connected to the emitter of second transistor. But here the connection somewhat, the transistor indication, it is somewhat we have to change. So for that we have to select and use the shortcut Control R, and similarly Control E also. Yeah. Now these two transistors getting connected. The emitter is connected and the base is connected between diode 2 and resistor 2, and in between two transistor we are having capacitor and resistor. So we have in between resistor and capacitor. And of course we have to connect ground terminal. Okay, now all the terminals are connected, as well as values also assigned. Now we have to give name also, so we can type it as class AB amplifier. To save, and we have to simulate. So while you simulate, we can see two windows, because we are going to check the input as well as output. For that you have to make two separations. So now we are going to check the input. So the top of the window you can see the input, and output also we are going. Similarly, by using the second window, you can check the output between two transistor. So the same way you can design class AB amplifier by using another tool, that is multisim. So here we have a class AB circuit and it should be simulated, and you can see the output waveform and the maximum amplitude, that is your input signal, and we are having the another signal also, the signal which is not properly switched because two transistor are required minimum time to make transition between them. So minimum of delay is always occurred, so this is actually called as distortion. So that should be eliminated by using proper biasing as well as diode method. So the same way you can design a class C amplifier also, like a class AB. Whatever the procedure we are following, the same way we are going to follow, and this is the actual circuit of class C. And if you simulate the class C amplifier, we are having the output response. So class C amplifier, so this is the amplifier which is going to amplify the signal with respect to particular frequency only. So here we can check the frequency exactly 3 kilohertz. So exactly at 3 kilohertz we are having the maximum amplitude, maximum gain, and remaining all durations from 0 to 2.9, from 3 kilohertz to 1 megahertz, we are having the minimum amount of gain. So this is one of the special type of amplifier compared to all other category, which will produce us the maximum amount of gain. Thank you, students.